Now, although I said that we're going to assume everybody is risk averse, we are going to talk about three different types of people. People who are risk averse, okay? People who are risk loving, and people who are risk neutral. Okay? Now, if you are risk averse, it means that you like a higher expected return and you like a lower standard deviation. Okay? You don't like risk. We're assuming if you're risk averse, you do like a higher expected return, but you like a lower standard deviation. If you are risk loving, you like a higher expected return and you like a higher standard deviation. You like more risk. Now, nobody in here was in that classification because nobody was willing to pay more than $10,000 in that heads or tails game we just did. Risk neutral means that you like a higher expected return and you don't care about standard deviation. Okay? Risk neutral just means it's not important to you. It could be a high standard deviation, it could be a low standard deviation, I don't care, is what risk neutral means. So, they all three like a high expected return. Risk averse, they like a low standard deviation. Risk loving, they like a high standard deviation. Risk neutral, they don't care about standard deviation. So let's draw some curves here. This is going to be our expected return on the vertical axis, and on the horizontal axis is going to be standard deviation. Now, if you are risk averse, your utility function will be such that your indifference curves are going to look like this. They're going to be going like this direction, like this. Now, if you remember from economics, everybody wants to move up to higher levels of utility. And these indifference curves are set so that you are indifferent between being up here on this indifferent curve and being down here. You're equally happy here, 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 and here. But you're happier on this indifference curve at every point of that indifference curve than you are at every point on this indifference curve. And you're happier at every point on this indifference curve than you are on every point of this indifference curve. Right? So the level of utility goes up as you're going in this direction. Now, this is moving up in the northwest because you like expected return if you are risk averse, and you dislike standard deviation. In economics, you would say that expected return is a good and standard deviation is a bad. Okay? So that's why you want to go in that direction. You want a higher expected return, you want lower standard deviation. If you are risk neutral, your indifference curves are, what do you think the indifference curve is going to look like if you're risk neutral? Any thoughts?
So it will be a straight line, sir.
They're going to be a straight line. It's going to be a horizontal line or a vertical line? Horizontal line, right. So this is our standard deviation. This is our expected return right here. It's going to be straight horizontal line. Because everybody likes a higher expected return, but you don't care about standard deviation, so you're equally happy being right here as you are right there. Okay, you don't care if you have a high standard deviation or low standard deviation, but you always want a higher expected return. Now, if you are risk loving, which means you like standard deviation and you like expected returns, okay, now someone who's risk loving would be somebody who would maybe be willing to pay $14,000 to play in that game. Okay? Because they say, hey, I get excited about the fact that there's a lot of risk in that game. I'm willing to pay extra money because I feel really good about, oh, I could be at $15,000 or I could be at $5,000. Okay? Now, we're assuming people are not like that, but that's what it means to be risk loving. Someone who is willing to pay a price in order to have standard deviation. Now, for them, the indifference curves are going to look like this. They're going to go in this direction because someone who is risk-loving wants to go up in that direction right there because they consider expected return to be good and standard deviation is good, both of them. So they want to go up in that direction all the time. Okay? So every point on this indifference curve is better than every point on this indifference curve and so forth. All right, so this is the one we're going to be working with, though, because this is someone who's risk averse. But it's important that we understand those concepts, all right? Because what we're doing right now is we're building what we call portfolio theory, modern portfolio theory. Modern portfolio theory is built on a few very important premises, okay? And not everybody agrees with these premises, by the way, okay? But it's important that you understand the concepts of these premises that upon which, these foundations upon which modern portfolio theory is built. And the first foundation is that individuals are risk averse. Risk averse means you like a high expected return and you dislike standard deviation. Okay. So what this is telling us here with this direction is, notice what it's saying. It says, as we take on more risk, if we start with a low amount of risk, we require a certain amount of expected return to compensate us for taking on more risk. But the more risk we take on, we require even more expected return as compensation for taking on that additional risk as we go on up there. Okay, so that's what this is telling us. And it's something called our marginal rate of substitution, if you remember that from economics. It is the rate at which we are willing to substitute expected return for standard deviation. Everybody's marginal rate of substitution is going to be different. Even people who, even though every single person we say is risk averse, how risk averse you are varies from person to person. So, for example, my mother-in-law is very risk averse. She doesn't want to take on any risks whatsoever. Okay? With me, I'm also risk averse, but I am willing to take on some risks if you offer me a higher expected return as compensation for taking on those risks. So let's draw my mother-in-law's her indifference curves and my indifference curves. My mother-in-law's are going to be very, very steep. They're going to go like this, okay? She's going to say, if you want me to take on some standard deviation, you better offer me a really high expected rate of return. So she has very steep indifference curves. For me, the indifference curves are still going to look like this, but they're going to be flatter. They're going to go a little bit more like this, saying, I do not require as much expected return as my mother-in-law does as compensation for taking on standard deviation. We both are risk averse because we both require extra expected return in order to take on some risk, but she requires a lot more than I do, so she is more risk averse than I am. Okay? So the slope of these indifference curves has a lot to say about how we feel about risk. So now what we're going to do is we're going to put together a function, and what we call it is what we call a utility function. The utility function will quantify our feelings about return and risk. Now, there are many, many different utility functions that can be used. The one that's used in your textbook is called a quadratic utility function. It's not the best utility function to use. I think the log normal utility function does a better job of showing how people actually behave, but the quadratic utility function is a very simple utility function. It will work for our purposes. So the utility function I'm going to show you here is the only one we're going to deal with, but I want you to understand that it is not the only way to show utility as a function of expected return and standard deviation. It is one way of doing it. It's just a nice, easy one. And so this particular function is going to say that your utility, the amount of enjoyment you get, is going to be equal to the expected return on an investment minus 1/2 times A times standard deviation squared, which is variance. That's going to be the utility function that we will be using. Okay? And again, the utility function just says how much enjoyment do you get out of an investment. This quadratic utility function says there are only two things we're interested in an investment. We're interested in expected return, and we're interested in standard deviation, or variance.